So I'm going to go over a couple things that come up in section 1-2 for domain issues. This one usually comes up each year. And there's a couple things you've got to do to find the domain restriction here. You've got a square root, so that's going to be an issue. But also you've got a fraction. And you can't divide by 0, so anytime the denominator is 0, that's going to be a problem. So we've got to look at both issues, both domain restrictions here, and kind of put them together. So let me start with the denominator issue. So we know that we can't have 0 for a denominator, because if you divide by 0, you get infinity. So I need to solve it out, square both sides. Y minus 10 is 0, y equals 10. So that's a problem. If y equals 10, then we'll be divided by 0. So right now, y cannot equal 10. I'm going to go ahead and kind of word it that way. Y can't be 10, because if it is, then we'll have a problem. So there's one domain issue or restriction. So let's look at the other part. Because this is a square root, we know that y minus 10 has to be greater than or equal to 0. So y has to be greater than or equal to 10. Okay. So there's the other piece. Now I would say the most common thing I see is this being the final answer for domain. So you just got to put these two things together. So y is anything bigger than 10 or equal to 10. But we know if we plug 10 in here, we have a problem. So as far as a final answer, y is greater than 10. Because if it's equal to, then we got a problem. And that's just plug it in and check and see. Plug in 10, you'll divide by 0, and that's not going to work. 65 is another one that comes up quite a bit. The book said to use a calculator on this. I really want to make sure you can do this by hand. On a quiz and a test, I am going to ask you to do this by hand without a calculator, and you need to be able to do that. So on this part, it's just a square root. It's not like 63 where we have two things going on. But that means this stuff here can't be negative. So we'll go ahead and work that out. 4 is greater than or equal to x squared. And hopefully at this point you're kind of seeing what's getting ready to happen. This is going to be one of those deals where you have a square root with an inequality, and it's plus or minus, the inequality is going to be pointing in the wrong direction. You need to do an interval test. Hopefully that's getting to be kind of something you're expecting now. You kind of see that coming. So we kind of not going to fully finish that because we've got to deal with the inequality part. But that's basically where it's going to end up. You've got plus and minus 2 being your critical values. So let's try a few things and see what works. Let's start with 0. It's a number that's in between these two critical values. And really I'm just checking to see, do I get a real number out or do I get a complex number out? So if I put in 0, well, 4 minus 0 squared is 4, and the square root of 4 is 2. But the important thing is I get an answer out. So let's try something bigger than 2, like 3. All right, well, 3 squared is 9. 4 minus 9 is negative. So tell you what, I'll write that out just so you're seeing what I'm talking about. 4 minus 9, well, that's going to be square root of negative 5. So that's not a real number. And if you try a negative 3 or anything smaller than negative 2, same deal. You're going to end up in the same spot. You're taking the square root of negative. So your domain is only going to work between negative 2 and 2. So for domain, I'm going to say negative 2 is less than or equal to x, which is less than or equal to 2. And if you're not sure about, I mean, it's got an equal sign here, so you should be good with the equals. But if you're not sure, what happens if you plug in 2? Does it work? Well, 2 squared is 4. 4 minus 4 is 0. That checks out. That square root of 0 is 0, so that's still a real number. All right, so there's your domain. Okay, I have asked you to find the range on this. Or the book asked you to find the range. And I know that can be kind of tricky by hand. I think the thing to really get familiar with in the book problems, these types where it's a number minus x squared or x squared minus a number, they're really only going to be either circles or hyperbolas or a piece of one of those. So if you kind of have a sense of what the function's going to look like, it's going to really help you know what to be looking for. But I think the best thing to do to get a sense of the range. And I'll give you a couple things to think about here. Let's go from -2 to, that's the only place the function's going to even exist anyway. And maybe just pick a couple nice values like -1, 0, and 1. Plug those in, see what we get. So if I put in -2 for the function, we just talked about if you plugged in 2, you get 0. If I plug in -2 for x, I'll also get 0. And let's suppose I put in, I'm going to start with 0 just because it's easy. If I put in 0 for x, I get square root of 4, so I get 2 for my y value. And if I put in 1, all right, 4 minus 1 squared is 3. Square root of 3 is up here. It's about somewhere a little bit bigger than 1.5. If I put in -1, I'll get the same thing. So hopefully you kind of get a sense of what shape you're getting here. And it is going to make a half a circle. And the tallest part is going to be right here at 2. The smallest part is going to be at 0 for y values, for range. So the range is going to be anything from 0 and up to 2. And that'll be your final way to put it. I guess one last way to look at this, it's square root of 4 minus something. So think about what's the biggest thing you could take away from 4 would be 4. And we can see a place where that could happen. If we plug in 2, that would happen. So 0 is the smallest this thing could be. If we think about what's the biggest thing it could be, well, if we don't take anything away from 4 at all, if this piece right here could be 0, then we would max out at 2. And it is possible that we can take 0, we can put something in for x that makes us get to 4 minus 0. Because if we put in 0 for x, that's where we end up. So probably kind of graphing it's the best way to think about it, but you can sort of logic your way through it too.